Section 3.5 is critical analysis. So we've done this throughout, throughout this course, but then especially throughout section 3, but we're going to formally do it now, where we look at data and we discuss whether or not it's reasonable. So we see data and statistical analysis in many aspects of our lives. Okay, we see it in newspapers and on the radio and on television. So a lot of this information that we're reading in these articles, it's not like just raw data where it's just raw information and we get to assess it. It's already been analyzed through the eyes of either the editor or the writer. Okay, and it's imperative to remember that networks and major newspapers, although they're careful about the way they present statistics because, lawsuits and they don't want to be liable for anything, they still publish bias. And it's important to remember that these people that are writing face tight deadlines. So there could be a lack of statistical knowledge when publishing a story. Okay, so just keep in mind that many times these sources are flawed. Okay, and they're flawed both unintentionally or deliberately. So it could be either one. Most of the time, you have unintentional biases, even from the researchers, but they don't mean to. So here are a couple things that we need to consider. Okay, and this goes for any journal article that's published. It goes for anything that you read on the internet. Is the sampling process free from intentional or unintentional bias? So sampling, we went over sampling, and it's how you collect the people that are going to be experimented on. Okay, and could any outliers or extraneous variables influence the results? So we actually took a look at outliers in section 3. We just recently talked about extraneous variables. Okay, could any of those actually influence the results? Are there any unusual patterns that suggest the presence of a hidden variable? And has cause and effect been inferred with only correlational evidence? So again, we talked about correlational evidence. The change in X and the change in Y can definitely have a pattern, but unless there's actually a relationship between the two, it could just simply be accidental. Okay, so the following are techniques that are used in order to flaw data. Okay, here's an example. Sample size and technique. Okay, a manager wants to know if an aptitude test accurately predicts employee productivity. The manager has all 30 current employees write the test and then compares their scores to their productivities based on their current performance. Okay, so what we're looking at here, we're going to look at score versus current performance. In order to simplify the calculations, the manager chooses every 7th employee to develop a baseline for whether or not the company should hire that individual. Is the manager's analysis valid? So he has 30 employees, he's going to choose every 7. Okay, that's 7, 14, 21, 28, that's only 4 employees. So in order to set the average, set mean, which is the average. Okay, first of all, here are some biases. Sample size. Okay, he's only taking 4 people to set that average. He should probably take all 30 because 30 is even, if n equals 30 is still a very low number. Okay, for that, but it'll definitely give him a baseline, but maybe over even more time he can collect more data and add them to the list. Okay, and the other one, the technique. Okay, every 7th person, that's too big of a person or of a chunk if there's only 30. Let's see what else. Aptitude test and productivity. So an aptitude test, it depends on what the aptitude test is actually measuring, because he would need to have it job specific in order to measure the productivities for each position individually. Because, for example, if you're a laborer, but the aptitude test is like how your critical thinking skills are, then those two are not going to align, because a laborer is just going to do like rote tasks over and over and over again, whereas a critical thinker may be more in project management or development or problem solving, right? HR, that type of idea, just as an example. Okay, so there are definitely lots of flaws in the way this manager is conducting his survey and his analysis. Okay, let's see if we can get the last one in here. Example 2, extraneous variables and sample bias. An advertising blitz by Math for Us Computer Company features profiles of some of its young graduates. Okay, so for example here, Courtney is a software developer, Peter's a programmer, Eli's a system analyst, Shannon, Bill, and Lynn. Okay, the number of months training, which is here, that these graduates took, their job titles, and their incomes appear. So months versus incomes. So let's analyze the company's data to determine the strength of the linear correlation between the amount of training and their incomes. Okay, and then we're going to classify the linear correlation. So let's go ahead and do that on Excel. Let's open this up. Okay, and we're gonna paste this. Oh, I want my headings. Copy. Okay, let's paste this. Move everything back to 11. Okay, and double click there, double click there. So pretty much I'm gonna take that. I'm going to, just like our other ones, insert, scatter plot, add trend line. We don't even have to do that. We just have to do that. Okay, and so this is income of graduates, and this is number of months training. Number of months training, and then this is going to be income. Beautiful. There we go. So if we blow this up, okay. Is it linear? Yeah, this could be linear, right? It goes up. Okay, as the number of months training increases, so does the income. So that's an okay. And then let's classify it. So this is the important thing to remember. So we'll do R equals, and we'll do equals square root bracket 0.8055. So our correlation coefficient is 0.89. Therefore, this is a strong positive linear correlation. Okay, so it is strong. So it is a good fit. And what would a student who graduates from the company's 2-year diploma program after 20 months of training earn? Does this seem reasonable? So 20 months of training. So let's actually just take 5.4423. Let's do 20 months plus 31. And again, I forgot that star. So 140. So is it reasonable that after 20 months, somebody's going to make it like $140,000? Okay, remember this is income in 000s. So no, that's not reasonable. No, it is not reasonable for a graduate to make $140,000 after 20 months. It also may not be reasonable for them to get 20 months of training, right? Usually you're on the job and you're making the company money. And we'll continue in the next video.